A natural gas electrical generation plant puts out an average of 312 megawatts of power for a year, and the process uses 4.36 kilograms of natural gas. What's the overall efficiency? Okay, so the efficiency is output over input. Okay, our energy output is going to be, I'm using power is energy over time. So energy is power times time. Okay, so that's going to be 312, and that's joules per second. And then it's for a year, right? Okay, so let's see, that's 365 days, right? Times, and this is days per year, 24 hours per day, 3,600 seconds per hour. And the seconds cancel, hours cancels, days cancels, and we'll end up with joules per year, which is exactly what we want. Okay, so 312 E6 times 365 times 24 times 3,600. That's a lot. 9.839 times 10 to the 15th joules. That's an 8. All right. So that is our output, right? And the question is, what's our input, right? Our energy input is just going to be the mass that we burn times the specific energy, right? So it's natural gas. We're going to use this guy, right? So it's 4.36 times 10 to the 8th kilograms times 55 times 10 to the 6th joules per kilogram. 4.36 times 10 to the 8th times 55 times 10 to the 6th. And this is equal to 2.398 times 10 to the 16th joules. Okay, so now, let's see, let's look at this. Now we can figure out our efficiency. Efficiency is output over input. So it's going to be, this is our output, 9.839 divided by our input, which is 2.398 times 10 to the 16th joules. I think we can do this. Okay. There's other ways to do this. This is just what's occurring to me. So this guy, I'm just using my up arrow, divided by this guy. And that is 0.4103. There aren't any units for that. It's joules per joule, right? So that's 41.0% efficient, which I think is pretty good for one of these power plants.